Our last video on this topic got a good reception, and you guys are asking for the second part, so let's go. So today we're going to be going over that. We're going to be doing this rig right here. I'm going to show you how to create all the controllers, connect them properly to the character, and make sure that it works and it moves exactly as we are expecting. Everything will be connected. We're going to have a neck. We're going to have the head joint. We're going to have all of this. We're going to look a little bit at scripting. We're going to look a little bit at the important things to consider about controllers. So let's go. Now, this part is also going to be a little bit technical. We're going to be going over controllers and how to make sure that they're all placed properly and we can use them to animate our characters. So what are controllers? Well, usually when we're working with a rig, when we're animating a character inside of a Maya, you are not going to be modifying the bones directly. This is a very simple rig, but there are more complex rigs where you might have even multiple skeleton sets that do a lot of fancy stuff, for instance, in facial rigs, and it's very difficult to interact directly with the bone. As you can see, it's very uncomfortable to try to click on that specific bone and move it around. So what we do for animators and as animators is we create a control rig so that we can move that control rig and generate the movement that we want. But we have a very important problem right here. This whole chain over here, this whole hierarchy of bones cannot be modified. It needs to stay exactly as it is to make sure that the deformation and the rig works properly. So we need to construct another hierarchy of controllers. I'm going to show you the principle of how this works. So let's take, for instance, the neck. I'm going to grab the neck right there, and I'm going to go to rigging. I'm going to turn on the local rotation axis. So as you can see, the neck has a specific rotation to it. X is pointing to the next bone, Y is facing forward, and Z is pointing, in this case, to the right. Controllers are usually objects that we can select, so curves work very nicely because we can press Alt and 1 to hide them. And a lot of people might think, oh, I'm just going to grab this controller, I'm going to snap it to the bone right there, and I'm going to rotate it a little bit and get it in there to work as a controller, like right there. But that's not how it works. If you do this, you're going to have a huge problem because, as you can see over here, this nerve scripts has a specific transformation to it, and all of these values on the scale and everywhere else, they're going to just be a mess. So there's a process that we follow to position the curve exactly where it needs to be while still keeping its values completely clean. And here's how it goes. The first thing we're going to do is we're going to create the curve. And before you do anything with that curve, you're going to group it, Control G. Now, I normally like to change the name to something like neck control so that I know that that's the controller that we're going to be using. And this group that we just created is going to be called neck control group. Now, what we want to do is we want to move this position or this element right here to the exact position where the neck is. But not only do we want to snap it there, we want to rotate it so that the local rotation axis of the group is the exact same one as the joint. This is going to make sure that when we do the constraints, which I'm going to explain in just a little bit, everything just works and functions the proper way. Now, how do we do this? We're going to grab the bone, its driver. Okay, so first the driver, who is going to call the shots, and then we grab the driven, which is going to be the group. I'm going to go to the rigging section, and under the constraint point, I'm going to go to this point constraint. I'm going to remove this option called maintain offset in case you have selected. I'm just going to hit apply. And what's going to happen, as you can see right here, is that my curve is going to jump, or actually the group of the curve is going to jump exactly to where I need the object to be. Now, I'm going to go back there very quickly, and instead of doing a point constraint, I'm actually going to do a parent constraint. Parent constraint not only moves the object to the position, it also orients it properly, which is what I forgot right there. So we're going to parent orient, and there we go. Now, you can see that the group right here, this neck control group, has the exact same local rotation axis. It's pointing to the next bone, and everything is just going exactly the way we want. Now that the group is where we want it to be, we can actually delete the constraint. We just use the constraint to position and orient things properly. We have a little bit of an issue here. As you can see, this curve is not oriented so that the circle is kind of like going through the X loop. So we can just go to the inputs right here and change the normal. Instead of Y, it's going to be set to X. And that tells it that the opening of the circle is going to be on the X axis. And since the X axis is, of course, oriented to the proper situation here on the neck, this is going to give us our shape. Now, this is where a lot of people, usually this is something that my students follow when I'm teaching rigging. It's like, oh, okay, I just grab the group, I parent constrain it to the bone, delete the constraint, and just modify the curve a little bit. But here's where you guys start making mistakes. You grab the curve and you're like, well, I definitely want to make this a little bit bigger. I want to push it up. And that just breaks the whole purpose of positioning the pivot point or the orientation of this element where it needs to be. So if you want to change this, if you still have the make nerve circle, you can change the radius here to make this bigger. You can actually go above this, so like a 20, or in this case, like a 30 or something. There we go. That's a little bit better. And if you want to change the shape, this is very important. You're going to right click and go into the control vertex mode. So I'm going to go here to show viewport, and I'm going to turn on or turn off the joints. We're going to go to the right view. And here, this control vertex, we can actually move. Like by moving the control vertex, you're not changing anything of the original rotation of the pivot point, because this is a component of the curve. So it's not that much of a problem. And usually the more important the curve is, the bigger it's going to be. So I'm going to make the neck curve quite big like that. Now, if I select the curve, as you can see, the pivot point is still where the neck joint is, and it's still pointing the way it needs to be pointing. And very importantly, it has its translation, rotation, and scales set to 0. We did not need to do any freeze transformation or anything, because by doing this, we're able to generate the proper connections. Finally, the last step that we need to complete the process of attaching this curve to our skeleton is to create another constraint. Okay, so let me go here to show again. Let's do the viewport joints. There we go. So the last thing is I need to tell this curve right here that it's going to be controlling that joint right there. So again, driver, who calls the shots, and then driven, who's obeying those instructions, right? And we're going to connect the rotation and translation of this thing right here. So that means that we're going to be using a constraint parent. Now, I mentioned that I was going to explain what a constraint is. So a constraint is an indirect connection between one component and another. It usually connects its translation, rotation, or scale, or all of them. And there's a couple of other like this aim and pull vector ones, but it will connect two components in a specific way. You can actually connect multiple components as well, but we're not going to go into that right now. So what this allows me to do is it allows me to say to Maya, hey, if this curve, like the neck curve, rotates, I want you to rotate the neck as well at the exact same value. If this curve is rotated, let's say 30 degrees to the front, then the neck joint is also going to be rotated 30 degrees to the front. It's just that. Why do I call it an indirect connection? Because when we do this, if I just do the parent constraint right there, you're going to see that the neck control is not inside the hierarchy of the joint. It has its own little hierarchy. And what's going to eventually happen is we're going to have a bunch of hierarchies all connected to the character as well. So now if I select this curve, you can see all of the elements are set to 0. But if we select the bone, there's going to be this blue line right here that tells me that it has a constraint connection. The blue, light blue color, it's an indication of a constraint on your asset. So if we grab this one and we move it, as you can see, the neck is going to move. And if we rotate it, the neck is going to rotate. So now I don't need to grab the joint. I can just grab this curve, and whatever I do or animate on this curve will move my whole character. All of these things that we just mentioned, the constraints, the proper positioning, the grouping of the controller, the constraint from the controller to the joint, that's like the overall look of how you're going to be creating a rig for your characters. Now, this is a very simple rig. We just call it a forward kinematic rig because each curve will control a bone. There's ways to do like more advanced stuff. We're not going to be covering them in this video, but I'm going to be showing you now how to do the tentacles following this exact same process, but using a little bit of scripting. So let's go. Now, we're going to talk about scripting, and scripting is one of those things that as soon as you mention it, artists go like, nope, I'm out. I don't want to do or deal with scripting. But it's actually a lot simpler than it might seem. Scripting is just a way to, in this case, automate a series of steps that you usually follow to generate something that's a little bit tedious, right? So in this case, we need to do this exact same process of creating a controller, grouping it, parenting to a bone, deleting the parent, and then doing the parent constraint from the curve to the bone for each individual element right here. On each tentacle, we have all of these bones, and if we want to control all of the bones with a forward kinematic system where each curve controls a bone, we need to do that. So imagine that we have what, like 7 or 8 bones per tentacle? That's going to be like very, very, very tedious. How can we solve this? How can we make this a little bit easier? Scripting. Now, I'm not going to go over scripting, but if you guys want, this script right here is going to be in our resource files in our Discord channel. So there's going to be, if you go into our Discord and you go to the channels, there's one called resources. It goes to a Google Drive folder. There's all of the exercises that we have here in the channel. Well, not all of them, but a lot of the exercises that we have here in the channel are going to be there. And there's going to be a text file with this thing right here. Again, I'm not going to like show you exactly what all of this means. I'm just going to like quickly go through it. But what this does here in Python is you import the commands, the normal like functions that Maya has, and I'm going to do the following. I'm going to select a series of controllers and select a series of joints rather. And for every point that I'm selecting, I'm going to do that. I'm going to create a controller. I'm going to group that controller. I'm going to parent that controller to the joint. I'm going to delete the controller. right here, delete, parent constraint, and then I'm gonna parent the controller, or yeah, the controller to the joint so that it modifies it. It's a very, very handy script. I learned this several years ago. This is not my creation, but it's really, really handy to do FK chains. So I call this the FK chain script. Now, the way this works is very simple. You just select all of the joints right here. Very important that your joints have the proper name. So as you can see, I'm gonna go over here and select all of them right there, except for the last one. Well, actually, let me just check if the last one has weights to it. No, it has no weight. Okay, so all of them except for the last one. And then, there we go. And then we just select this whole thing here on my script editor, and I just run it. And what's gonna happen, as you can see right here, if we hide the geometry with Alt-2, is that every single piece of this tentacle has now a little curved circle that's already parented to the next one that is already connected to the joint. So you can see that the joint is moving, and they already have, I know it's beneath my, let me close this, right there. So you can see here, we got the proper connection going on that left tentacle group. So we got left tentacle control, left tentacle group. That's exactly what we're going for. Another thing that I really like about this one is that since it's using a script, every single curve still maintains its original input. So I can go over here, go to the radius, and just change the radius a little bit so that we can select everything here. So something like that. I'll probably go to a couple of these guys and just make them a little bit smaller to make it so it's a little bit easier to work with. But yeah, that's how the script works. So that script right there, the only thing that it did differently to this one right here is that it automated the process. Again, creates a control, groups it, positions it where it's supposed to be on the bone, deletes the constraint, and then creates the connection between that bone and the controller. And if you have multiple bones, which is what we have here on the tentacles, it does this. However, you don't need multiple bones. Like if I just grab that bone right there, like a single bone, which is the head bone or the neck, oh, that's not the neck bone. Oh, let me see if I can select, there we go, the head bone. If I run this, it's also gonna do it, and it's just gonna be a single joint right here. Again, you can't see it, but there we go. It's just a single joint. So if you just need to position a single joint somewhere, this is a perfect way to do it. Okay, on this one, for instance, I'm gonna change the rotation, and I'm gonna change this to Y, because it just makes a little bit more sense for the joint to be like that. We can isolate it, go into the control vertex, and change it. Okay, let's go to the side view. Let's isolate it again. I'm just gonna kind of like move this back here. I'm gonna show you how to add colors to the curves as well at the very end of the video. But this one's gonna be my head controller. And if you go online and you look at rigs, there's gonna be some rigs that has some very fancy controllers. But just curves like this, just circles, it's more than enough. Like if the controller looks very fancy, it's not gonna make you a better animator or anything. It's just gonna look fancier on your stuff. So yeah, now again, let's grab for instance all of this ones right here. So I'm gonna grab this tentacle 1 all the way to tentacle 7. We open our script editor, we run the script again. And as you can see right here, there we go. We got all of this CF tentacle group, and we're gonna have all of the curves right here. So each curve has its group, each curve is set to 0, it has no information, and we can just grab all of them, go to the radius, and play a little bit with the radius right there. So I'm gonna go right around there, I'm gonna grab this one, I'm gonna change the radius to like a 12, and then we got another one right here, and another one up here. This one's I'm gonna make like, I don't know, like a 15 or something. So remember, if you want to modify the components, for instance, if you want to make this a little bit spikier, go to the controlled vertex. Do not scale the object. You always want the information of your curves to be completely clean. And I'm not sure if I repeated this on this video, but the file, the actual like low poly head, it's available on what's the word, on the resources folders. So if you saw the first video or you haven't seen it, make sure you watch it to know how to place the rigs right here, the bones, and then come back here to do the exercise. So I'm gonna skip the next step, which is I'm just gonna add a bone to every single piece that I'm missing, and which is all of this like 3 eyes that we have right here and the other 2 tentacles. And then I'm gonna come back to show you how we can customize the colors of the elements a little bit more, and also how to group some of them to get a little bit more control. So hang on tight, and here we go. Very well, my friends. So as you can see right here, I got all of the necessary like curves, but this is becoming a little bit difficult to see, especially here on the eyes. All of these curves right here, they are getting really complicated to see, right? So you can see that they're not facing like the right way, or not the right way, but they're not facing the way I think would be a lot easier for animators to see. So I'm gonna grab all of the curves right here. And the first thing I'm going to do is I'm going to change their rotation. So instead of X0, it's going to be Z0. So they're facing forward, as you can see. And then I'm going to isolate all of them, go into control vertex mode, and I'm going to push this. Now, in order to make this as precise and exact as possible, I am going to go here to my, my grid snap, and I'm just going to snap all of them one grid forward. So there we go. So that's the position right there. Let's bring the head back. As you can see now, all of these points are going to be a lot easier for my animators, or for me if I'm animating, to select the whole element. Let me hide them again. One last thing I want to do is just want to make them a little bit bigger. So I'm going to change the radius to something like a 3. There we go. So we got this already. This is looking good. But again, from a reading perspective, we're not really reading the elements. It's the same color. It's blue as a character, which is this sort of like a teal or light blue color. Now, in order to change the colors of our curves and make them read a little bit better, I'm going to select one of these curves, like this one right here, and we're going to go all the way down on the neck control shape to this option called Drawing Overrides. You're going to select Enable Override, and then down here on the color, you're going to change to RGB so that we have access to our colors. And in this case, I'm going to select red. Usually what we do when we are like assigning colors is we try to keep the center controllers the same color, so that again animators know that that's a center controller or center controller, and all of the rest of the elements we try to add a specific color. Now I'm going to be using another script. This is a new script, and this is a courtesy of a Reddit user that posted this like 7 years ago, that allows me to very quickly set a specific color for my curves. Now in here, I'm going to actually add a note so that when I share this with you, my friends, you can do it as well. If you want to add notes, you can use this one right here, the little hashtag symbol. So let me very quickly check here. There you go. So the number on the index is the number that you're going to be replacing. So as you can see, the number 13 right here is going to paint all of my curves red. So if I wanted to paint all of them, in this case, green, all of the left ones are going to be green. I'm going to change this value to 14. So I'm going to select all of the curves right here. And what this script does is does exactly the same thing that I was just showing you, but you cannot select all of the curves at the same time. So this just makes it a little bit easier. Just grab all of this thing, run this, and there's an invalid syntax. Oh wait, this is actually a mel string. So I'm going to copy and paste this onto the mel element right here, and it should run here. There we go. So now, as you can see, all of my curves are green. I'm going to do the exact same thing on this one. The difference between a Mel script and a Python script is that the Mel script is written in like Maya's embedded language, so Maya's own language, and Python is written in like Python language. Let's change this again. Let's change our little number right here to 6. So we do the blue color, which should be a little bit more of a deep blue color. Let's run it and see. Yep, there we go. Now, one thing, if you want, you can literally, I'm going to go to the rigging tab, which is where I'm going to be using this. You can middle mouse, drag and drop this into the shelf, and that becomes now a button. So if I select all of my curves right here, all of this guys right here, and I click the button, all of them turn blue. So that's another way in which you can quickly modify all of these elements. I'm going to grab the center back tentacle right here. And if I want to modify this button, just right click, edit, and here again we change the value, which was 13 for red. There we go. And then when we run it, that's going to be red. And finally, I'm just going to do this manually for the last tentacle. I'm going to make this tentacle yellow. So give me just a quick second to do it. And there we go. As you can see, with this done, our rig is now complete. The last thing that we need to do to make sure that all of this moves together is we need to find a way to make sure that all of our systems here, because this is what we're pretty much doing here. We're creating systems. Let me just collapse everything so that we can see it. All of the systems right here, they need to follow, let's call it a major sort of system, right? So all of the tentacles, tentacle group 1, center front tentacle, center back tentacle. What's this right here? Center back tentacles, right tentacle group right here. That one, oh, is it the right one? Yeah. This one right here. Oh, wait, we have 2 systems. Oh, that's a problem. Seems like I made double this one. There we go. So center front tentacle, right tentacle, center back tentacle, and left tentacle. There we go. All of these groups are going to be parented to the curve. This is very important. To the curve, not the group, to the curve. I'm going to parent, just normal parent, just hit P. And now if we move this curve, all of the tentacles are going to move. And the same thing is going to happen with all of the eyes. So the eyebrow, 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 all of those groups are going to be parented to the curve. Just hit P. Select all of the groups, select the curve, and hit P. So again, when this curve moves, every other curve is going to move with it. And then independently, of course, each curve can move on its own. But we're creating this hierarchy. Then this one right here, the head group, is going to be attached to this one right here, which is going to be the neck control group. And normally there's going to be something called a root controller. I don't have it on this one right here because the root controller is just this bone and it's relatively easy to select. But since we're just following everything properly, let's do it very quickly. So I'm going to go. It's also a good way to just go over the whole thing. We create a curve. We immediately group it. We select the group. We select the joint, the joint, and then the group. There we go, and we do constraint parent so that the curve jumps exactly where it needs to be. Now that we have that, we can delete this constraint. We're going to call this a root control, and then the group's going to be called a root control group. Now this root control, we're going to rotate the center axis. So it's going to be facing X, and then we can grab the curve. Let's isolate it. Let's make it a little bit bigger, and we can even like move it down here. Okay, it doesn't really matter where the curve is because the pivot point is going to be, it's always going to be like up there. We select the curve, the driver, and then the driven is going to be the joint, and we do a constraint parent as well. We grab this one right here, and that allows us to move it, everything. Finally, we need to grab the neck controller group and normal parent it to the group right here. So now if we move the root controller, my whole rig is going to be moving as well. So yeah, that's it, my friends. I know again that this tends to be a little bit technical. Hopefully with this explanation, it makes sense how things are connected usually on a rig. This again is a very, very simple rig. There are way more advanced rigs that you can do, but this should give you enough control to just, again, grab, for instance, this curve right there. Oh, this one right there. And if we want to animate that little part, this little part, or this little part, we can do so very, very easily. The more bones you have, the more controllers there are. There are other systems such as IK change and things like that. And yeah, that's pretty much it. We are missing part 3. So let me know in the comments if you want to see animation and how to maybe get this into an engine. We can go over that. It's relatively simple. The last thing that I want to do here is just a very quick cleanup. So I'm going to call this mindflayer_geo. As you can see, we have all of these extra groups that are not doing anything. So let's just delete it. And we should have all of this right here. We have the geo, the root controller, or in this case, the bones, which call this the deformer bones. And then we have the controller setup. One last thing I want to talk about, and this again, it's a little bit technical, but it's important for you guys to understand. The joints and the geometry, the connection between the joints and the geometry can be kept between softwares. So if you're working on the skinning inside of Maya and you want to transfer this to Blender to animate in Blender, or the other way around, the FBX file that we normally use will hold the weights of the joints to the specific vertex of your geometry. But all of the parent constraints, all of the grouping that we have, all of the controllers and curves that we're creating, they're not compatible. So it's very important, especially when you're planning a project, to decide very early on where you're going to be animating. I'm going to give you a quick example. Right now in the studio, we're working on a project that should be done in like 2 weeks. And earlier in the project or in the process, my artist told me that they wanted to do the modeling and the UVs and everything inside of Blender. But I told them, yeah, that's fine, but we're going to be animating in Maya. So we're not going to do any sort of like a rigging inside of Blender because in this case, the tools that we're using are a little bit easier to manage here inside of Maya. So that's it. Let me know again in the comments if you want to see part 3, which we're going to be going over animation and the engine process, or how to export this into an engine. And that's pretty much it, guys. Thank you very much. You now, after all of this time, if you're here at the very end, again, thank you, because you now have knowledge that not a lot of people out there have. I'm going to be honest with you. When I started learning rigging, I became a better modeler because now I understand how things deform, and that allows me to place my polygons and my proportions and everything a lot cleaner in the modeling process so that I make the job of the rigger a lot easier. So you now have the knowledge as well. There's of course more things that I can show you. Let me know in the comments if there's specific things that you want to learn, and I'll be happy to add more videos here into the channel. If you want to support us, we have the premium courses available down here. We even go a little bit over rigging in our introduction to Maya course. And yeah, that's pretty much it. Make sure to go to the Discord, follow us, like, share, and I'll see you back on the next one. Bye-bye.